to discuss about these FPGA boards. Hopefully this section would have helped you to decide on a good board that's right for you. Now I'll move on to the final section, which is a step-by-step guide, where I'll use the Xilinx software tools to get the Mercury FPGA board to flash its LEDs. Alright, so I'm just going to get started on installing the software for the Xilinx ISD design pack for the Mercury FPGA board from Micronova. And here I'm going to assume that you're starting from scratch, that you don't have any other tools installed, that you're just starting from a computer that's not configured at all. Start off, I'm going to visit the webpage for the Mercury FPGA development board at micronova.com/Mercury. And this is the page for the Mercury board, and it just briefly talks about the board here. To get the tools that you need, just start off at getting started with Mercury. And we'll be provided two links here. This one is the design suite from Xilinx, which is called the ISD webpack. This is kind of the design environment that you require. Micronova provides a programming tool that allows you to take a zip file that this webpack generates, and you can upload that file to the FPGA board with just a simple tool through USB. Otherwise, you'd have to do it through JTAG, and that's a pain, so you also need this tool as well. This is the link to the Xilinx's various products that they allow you to download for free. Just make sure that you do not get the Vivaldo design pack. This one's for Xilinx Vertex and other really high-end FPGA tools, or FPGA chips. So you would have to go to the ISD design tool. And Xilinx offers kind of an interesting option here. You can either download all the files that you need separately, because the really bad thing about downloading this design suite is that it's 6 gigabytes in size. But here you just download it in 4.2 gigabytes, or you can just do a single download actually. So it's 6. So you can just pick an option here. For me, I prefer to just go with this entire file, and I'm running a Windows operating system, so I'm just going to go with this link. And obviously, if you have Linux, you know that one. I'm just going to continue here. You would also have to register with Xilinx to download these tools. Just going to enter in my credentials now. And after you go through the registration successfully, you should see this page. And as you can see, the download for the design suite is already started. So yeah, you can see, I'm not downloading very fast, but yeah, it's 6.2 gigabytes, so that's just going to take a while. So now that I have that downloading, I can download the programming tool from Micronova and kind of Windows operating system. So I'm just going to get this one. And it's not nearly as big, so that one should take a few seconds. I already had installed this programming tool, that's why it's asking me this, but otherwise you just start the MSI and then just go through the wizard and get this all installed and ready to go. Alright, so what I'm going to do is I'm just going to wait for this download to complete, and I'll get back with you when it's done. Okay, so the download is completed, and yeah, I have the firewall here. You can use any number of extraction tools to extract this. So here I'm just using 7-bit, and it looks like it's going to take a while too, so I'll just get back with you when this is done. So I finally got that guy extracted, so I'm just going to open this folder. And yeah, that's all you have to do is just start this FTP tool. Seems easy enough. Don't judge me for just checking those. Just feeling that this was not the one I want. Pretty sure I just got this ISD webpack. Considerable programming logic devices installed as the inside FPGAs, and that would include the Spartan FPGAs that we're developing. So I feel this would be the correct one. I'm just going to go with this one. What happens if I uncheck this? Okay, so hopefully I did everything right. Looks like this is going to take a while again, so I'll just see you when this is done. So we have everything installed now. I'm just going to start the design suite. Then from here, I'm just going to select new project. So the name of the project, I'm just going to name the project Link LEDs. And at this step, you are selecting the parameters surrounding the FPGA on the board which you are developing on. In our case, for me specifically, I'm developing on the Mercury FPGA board from Micronova, so I will be selecting the parameters for the FPGA which is on that board. If you have a Mojo or if you have a Nexus 2, these parameters are going to be different for you. You can confirm that we're using the Spark 3A, and for me, I'm using the 200,000 gate equivalent FPGA. So you want to make sure that you have the Spark 3A selected here. And you can see for the 200,000 gate equivalent, it uses the XC3F200A device model, which is that model here. And then finally the package type, the 100DQ, DQ100. Now this is a speed grade, and you have two options here, -5 and -4. -5, I believe, is for a higher speed and for commercial use. So in this case, just leave it at -4, and then finish up the project. Now before we get started with this project and get our hands dirty, we must first define what is the goal of this project exactly. The goal for our project is to control the Spartan 3A FPGA in such a way where it's going to turn on all of LED for 1 second, and then turn off the LED for another second, and then simply repeat that pattern. Now, when you're developing on an FPGA, it's a good idea to create a map of how your architecture is going to look like. In this case, our architecture is going to be very simple, so it's just going to be a very simple map. Now, take a look at this diagram. This gray box here is the Xilinx Spartan 3A FPGA that we're developing on. And this purple box surrounding it is the Mercury board. On board, we have a 50 megahertz crystal oscillator, and we also have 4 LEDs, which is as depicted here. Now, inside the FPGA, since this design is really simple, we only need one module here. And this module is going to take in a clock input, and then it's going to control the LED connected here. So we're going to make it in such a way where we want to design a module that's going to take in this 50 megahertz clock, and then do some logic here in such a way where it's going to turn on the LEDs for 1 second, and then turn them off for another second. So we're going to want to eventually wire this with this clock 50 megahertz crystal oscillator to our module, and then this module will be connected to our LEDs, which is on the Mercury board. Okay, so now that we have that out of the way, I'm just going to go ahead and define that module right now. Just right click on the FPGA, and switch. Now we're developing a VHDL module, so we're going to select VHDL. Great. So we're going to select the HDL module here. For the name of the custom, they name it Blink LED. Now at this point, you're going to define what inputs and outputs that this Blink LED VHDL module is going to have. Now remember that this module has the clock input, and then it has the LED output. So that's just what we're going to define here. So we can name it clock, which the direction is in, it goes into the module, and then the output is LED. Let's go now. Now the thing about the LED though, is that it's also a bus. As you can see here, it's a bus that goes from 3 down to 0. So this arrow really represents 4 lines. So it kind of looks like this. But these LEDs also are 4 lines. There's 4 lines that connect to these LEDs. Because these LEDs are connected to 4 different pins on the FPGA, so that's why we're creating the LED bus with 4 signals. So that way each signal is going to connect to each one of these LED pins. And you can see that for yourself. If you go to the Micronova Mercury product homepage and select the schematic, you can zoom in here and see the FPGA. The FPGA consists of each one of these banks that you see here, and also these other units as well. And you can see FPGA is labeled here, and it's within this blue box. So even though these are a bunch of different modules, it's just made that way to simplify it down. And you can see that it's just here's the XG3S200A, and each one of these blocks are labeled that way. So you know that these 6 pieces are actually one IC. Now the LEDs are hooked up right here, pin 13, pin 16, 15, and 19, and they're called LED 0, 1, 2, 3, and the signals are connected here too. So that's what the module is going to do. The module is going to exist within the FPGA, and it's going to be wired directly to these 4. So I may have over-explained that, but we're going to focus on LED box. And to do that, this is supposed to be the most significant bit and the least significant bit. It's going to go from 3 down to 0, from 0, 1, 2, 3, to 4 different unique signals. And we're going to finish this, and then Xilinx is going to create this sort of skeleton code, which you are just going to fill in with the logic that you want. So you can see it has the clock input and it has the LED output, and you can see that the clock is declared as something called a standard logic, and that's because it's only 1 bit long. So when you have an input that is 1 bit long, you declare it as standard logic. But our LEDs is 4 bits long.